is. And so at the end of every year, people ask us, well, how hot was it? And 2014 turns out to be a record year. That's the warmest year in our instrumental record, which goes back to the late 19th century. It's about 1.5 degrees Fahrenheit warmer than it was in the 19th century. The previous record warm year was in 2010. Before that, it was in 2005. Before that, it was in 1998. So if you think that this is a story you've heard before, you're right. There are more and more records being broken on a pretty regular basis, not every year, but the planet is warming. And so as the planet is warming, you're expecting, because of that internal variability, some of that weather, to get more and more records. Any individual record is not that important, right? That 2014 was a record and 2013 wasn't, that doesn't really matter. What matters is the long-term trend. The long-term trend is up. It's consistent and coherent with what we understand about what's causing that trend, which is mainly the increase in greenhouse gases over the last 150 years, mainly from the burning of fossil fuel. And what you find is that there's always structure. Right? There's always places that were warmer than the average, and there's always places that are a little bit cooler than the average. But the baseline, the global average, that's what's going up year by year. But it's not that everywhere is having a record warm time exactly at the same time. So this year we had record warm temperatures in Alaska, Oregon, Washington State and California, but on the East Coast it turns out to be one of the only places in the world that had a colder than normal year. So a lot of the weather that we see, a lot of the atmospheric circulation is affected by patterns of temperature in the ocean. And all the heat, almost all the heat is going into the ocean. That is being reflected in the surface temperatures, and it's impacting the weather that we're having on land.